Good morning. Welcome to MongoDB.local Chicago. How have the sessions been so far this morning? Great. Well, we have a full ballroom, and I know there are many also watching on the live stream. Thank you all for being here. I'd also like to say a special thanks to our sponsors, Townsend Security and DataVeil, for helping make this conference possible. MongoDB Chicago is a learning conference. Each year, we put together a technical program designed with the audiences represented here in mind. This year, advocates throughout the MongoDB community, customer teams in organizations large and small, and of course, MongoDB engineers have worked to put together a program that we think will really meet your needs. Our objective is that you leave each of the breakout sessions with new knowledge you can take and apply in your own projects and within your own organizations. The keynote is no exception. We've got a great talk packed with some exciting new info and a bunch of really great demos. So without further delay, I'd like to introduce the CTO and co-founder of MongoDB, Mr. Eliot Horowitz.
So when I got here this morning at around 7 a.m., for the very first time in my career, really life, I was told I was too tall and that I had to stand at the very front of the stage or I was going to block the screen. This has never happened to me before. So you guys, if I fall forward, I'm going to fall right there, actually. Which reminds me of the last time I was in Chicago, which was last year when we had MongoDB World here. So it was a big event, gave a talk in the morning. That evening, there was an after party. I was talking to a couple of people. One of the guys I was talking to clearly didn't recognize me. So I asked him how he thought the keynote was. He wasn't super impressed. He asked me what I did. I told him. He was like, "You're lying." I show him my badge. He's like, "Oh, I thought you'd be taller." So seems to be a theme in Chicago. So this morning, we're going to talk about a lot of the cool stuff that came out in MongoDB 4.0, a lot of the cool stuff that we're working on now that's coming out in the future. And I would say I've got a few interesting things to talk about, a few cool demos we're going to show you. But really, my main goal is to get the couple of people I saw playing Candy Crush to actually be more interested in the talk than Candy Crush. But that's probably a pretty high bar. So without further ado, I thought we'd first talk a little bit about sort of the way we think about things and what we're trying to do. And what we really believe is that MongoDB is the best database for modern applications. Okay, well, that of course begs the question, what is a modern application? And I would really characterize a modern application as three things. One, it has to be built on a foundation that has incredibly high developer productivity at its core. Right? Developers are in higher demand than ever before. Features and new products and new ideas want to come to market as fast as possible, and competition's only getting harder and harder. So every modern application has to have developer productivity baked directly into the core, or it really won't succeed. The second is infrastructure agility. So what does that mean? That means that it has to be able to be deployed anywhere. So on different clouds, in the private cloud, you develop it on your laptop. It also means things like it has to scale up and down very easily. It has to adapt to new regulations and new laws that say where data has to live. And really not care where it's deployed or how it's deployed or what things are on top of it. It's got to be very infrastructure agile. And third, it has to have incredibly good user experience capabilities. So for example, incredibly low latency. Right? Users don't want slow applications. It has to be able to handle things in real time. Right? No one wants a loading screen or to say, OK, great, your request will be looked at in 20 minutes, or how often do you click on that link in some application that says reset your email password, and it says 5 to 10 minutes. It's like, no, I want to do it now. I don't want to wait 10 minutes. So real time, very low latency. And if an application, if the foundation of an application can't handle these three things, it's not very useful. So why is MongoDB particularly well suited for these three things? Well, it really comes down to our three core principles. So the first one is the document model, right, the foundation of MongoDB. The second one is how we use distributed systems. And the third is that you can run MongoDB anywhere. So let's look at the document model. So the document model is great for a number of reasons. The first one is that it's natural. Right? When people think about their friends, when you think about Bob, you don't decompose Bob into 1,000 little tables and break him apart. You think of a person as a person. I guess for a lot of programmers here, so that might not be true. But generally, people think of people as people, or cars as cars. They don't want to decompose a car into all of its components to store it. They just want to take that person and store it as it is. And in MongoDB, you can do that. When you're working with any modern programming language, you are using documents or an object or some sort of structure. And documents in MongoDB are very well suited towards that, because you take your structure in your code and just store it in the database. APIs, REST APIs are mostly JSON. JSON is obviously very well suited for the JSON document model. So that all works really well. Second, as you're developing your application, the schema often wants to change. And with the document model, you've got a ton of flexibility to change the schema as you need it, to adapt it, to add fields, do different things. But at the same time, we have features like JSON schema where you can have the right amount of enforcement at the database layer. So you can say things like, this document has to have an age field that has to be between 0 and 125. You can have other validation rules there. So you can have some level of enforcement at the database, or maybe a lot of enforcement at the database, or very little. And it can depend on the application or even on the collection. And of course, we have the best query language for querying documents. Right, so the query language lets you write very intuitive queries for building queries, for doing analysis, for doing real-time analytics. Everything you want to do with the data, you can do it right in the query language. So now you combine that with distributed systems, right, our second core principle. And distributed systems give you things like built-in high availability, so you don't have to sort of build that on top of the database system. It's all built in from the core. It gives you scale out, so you can scale up and down elastically very easily. It gives you workload isolation, so you can actually have different nodes in a cluster doing different things. For example, you can have a 5-node cluster and have 2 nodes dedicated for analytics workloads and 3 nodes dedicated for transactions. Right? So your analytics, your business users can do whatever they want to those 2 nodes, and they're not going to impact your production traffic on the other 3 nodes. So that makes it really nice to be able to do things like that. And in addition, you're not managing some external synchronization system or some data warehouse that you've got to synchronize data to. You can just have one cluster and just isolate workloads based on what you need to do. And one of my favorite ones is zone sharding. Right? And zone sharding lets you put different data in different places. Right? So you can keep data for your European users in Europe, your Australian users in Australia, the American users in America, comply with laws and have lower latencies, all within one cluster, so you can manage that logically. And of course, you can run this anywhere. You can build the exact same application on your laptop, on a mainframe, in your own data center, or in the public cloud. You've got the exact same code base, the exact same code. You can start it on your laptop, deploy it to the cloud, start on-prem, move to the cloud, start on the cloud, move to on-prem, whatever you want. The exact same, the application is just the application. Same database everywhere, all with all the sort of the same security features, the same security capabilities, no matter where you want to run it. So really, these 3 principles are what makes us think that MongoDB is the best database for modern applications, for any use case and on any platform. So what we're going to do for the rest of this morning is talk about how we've improved MongoDB in these 3 ways in MongoDB 4.0 and coming soon. So the first thing we're going to talk about is the document model. Right? What have we done to the document model to make it better? So first, we're going to talk about transactions. So I'm sure most of you know that MongoDB 4.0 that came out in June has multi-document ACID transactions. So MongoDB did go on a trip. And so what are transactions in MongoDB, and why might you use them? Right? The document model negates a lot of the needs for transactions, but sometimes you really do want a transaction. So let's look through an example. So here we've got an e-commerce system. So what we're going to do is insert an order into an orders catalog. Right? So the order is the first line, then we're inserting it into the orders collection. or you're placing an actual order. Then for every line item we purchase as part of that order, we want to decrement an inventory count so we don't oversell like we're selling actual physical goods. Does all make sense? Okay, but what happens if the program crashes right here, right, or right here? Now you're left with an inconsistent state, right? You've approved an order, but you haven't decremented your inventory count. Now, there are ways to handle this in MongoDB, to go back and check, to clean things up after the fact, but it's frankly kind of annoying. It would be better if you can just handle this in a transaction. So in MongoDB 4.0, all you have to do is this. So you start a transaction, you add that transaction to each one of your operations, and you commit. Which really is sort of brings me to the first sort of one of the main characteristics of transactions in MongoDB, which is that they are incredibly familiar. They're exactly like transactions you've used before in any traditional relational database. You start a transaction, you do your work, you commit, you abort, exactly the same. They're fully conversational, right? You can do reads, you can do writes. If you do some reads inside of the transaction and do some writes dependent on that, if there's a conflict, it's going to get aborted. This isn't some newfangled, weird version of transactions that's trying to like work around what people actually want. No, it's just actually regular transactions that people have been using for the last 40 years that are done in a MongoDB way. Very, very familiar. And they're fast. So first, if you're not using transactions in MongoDB 4.0, no penalty. We didn't have to change this core to make it slower. A lot of changes, nothing that made it slower. And if you're using transactions, they're also quite fast. So a few months ago, I promised some numbers. We're getting there. So we finally have some interesting benchmarks that are interesting. And these are based off of, we have this benchmarking tool called SocialLite. It is basically a social network as part of an application. It's open source, so you can go play with it. The link's down there, but it's easy to find. And we've got a couple different things here. So the first thing we're going to look at is it's got 4 different scenarios in it, just doing different kinds of things in it. These are all non-transactional workloads, right? Just regular MongoDB operations. And what you'll notice, in the first one, MongoDB 4.0 is actually quite a bit faster. We've done other stuff in 4.0 just to make things faster. And every other scenario is basically the same or slightly faster in MongoDB 4.0, just because as we generally improve things. Same workload, no penalty cost whatsoever. For the second example, what we're doing is we're going to change our schema a little bit and make the app a little bit better, but a little bit more complicated. So in a social network, the main thing you want to do, let's say for friends, is for each person, store the people that they are following. Right, that makes sense. I've got a document. I've got Eliot's document. Here's the list of people that they're following. And you can do a query that says, OK, find me everyone who's following Eliot, right? Sort of the inverse of that. And that's pretty easy to do. But if you're in a really big sharded cluster, that could actually be kind of slow if you get lots of followers. So in many cases, what you want to do is denormalize that slightly and have a separate document that says, OK, who is the list of people who are following Eliot? Right, so you've got one document going from the who is Eliot following and one document who is following Eliot. So what we've done in the second example is the original schema just had one way. So we've added the second way. So now we're doing both directions. And we're doing that in a transaction so that it's not so that they're in sync. And what you notice actually, so now the second graph is showing that we've added the second operation and used a transaction, and it's 2.5% slower. So there will be a blog post coming out on this very soon, we think. But if you don't want to wait for the blog post, you can actually just go and run it yourself and go play with the data. It's all right there on that URL right there. So in MongoDB 4.0, we have replica set transactions, right? So transactions inside of a single replica set. And in 4.2, which will be our next version, we'll support multi-document ACID transactions in a sharded cluster. So we haven't sort of started transactions recently. This has been a pretty long-term project. So it all started in MongoDB 3.0 when we introduced WireTiger as the main storage engine for Mongo. And we've been building this over the course of many years. As you'll notice, by the time we release 4.0, the bulk of this work has been done already. And there's just a little bit left to get done in 4.2. And already a lot of the unit tests and sort of tests for sharded transactions are already in the code base. So, and given that we're open source, you can just go and start playing with that as well. If you want to learn more about how we've built them under the covers, you should check out Keith's talk a little bit later today. He was the creator of WireTiger. And next, I think it would make sense to talk a little bit about when you should use transactions and when you shouldn't use transactions. Right? it's definitely not the right idea to say, hey, I've got this relational data model. I'm just going to like port it over to Mongo and use transactions for everything. We actually think that most applications that use Mongo will probably use transactions, but for a very small number of things. Right, the document model in MongoDB lets you not need transactions nearly as much as you do in a traditional database, but sometimes you do. So first, let's look through a quick counter example. So let's imagine we're doing our e-commerce site again, and we've got in a relational database, how would we model it? Right, we'd have an orders table and a line items table. Right, and every time you'd modify the orders table and the line items table, you would do a transaction to keep them both in sync. That makes sense. So in MongoDB now, you can do it that way, right? You can have a transaction. So every time you want to go and insert an order, you do a transaction that inserts stuff into the orders collection and to the line items collection. But of course, this is exactly not what we want to do. Right? You don't need to do that in MongoDB. You should store this in a single document. And you can still do interesting things, like here's our orders document, and you can still go ahead and do things like update every line item using sort of our query language. Right, because it's powerful enough to actually be able to understand arrays. So in this example, we're actually updating every line item's price and multiplying it by a discount. So when should you use transactions in MongoDB? Well, the first example really is when there are distinct business objects. Okay. So an order and a line item, they're not distinct business objects, right? A line item is clearly part of an order. But orders and inventory are kind of distinct, right? Inventory counts how many products you have sitting in a warehouse, and an order is an actually order from a person. Those are pretty distinct. People, right? Eliot and Bob, distinct business objects. And yes, I guess people are business objects. But anyway, that's a different question. So different business objects. A car and a person, different. A car and its tires, kind of the same thing. Second, maybe you have some sort of e-commerce application, or maybe you've got some finance application, and you've got tons of events streaming in. And the first thing you want to do with those events is store the events just raw in the database. But maybe in a transaction, you want to store the event in the database and update some view, right, that maybe has the latest stock price for something, or the total number of money spent in your store. Whatever it is, now you can have a single transaction that updates the sort of the core collection and the ancillary collections you have maintaining some views or rollups. And then in 4.2, there'll be a whole bunch of other really cool things you can do. Like, for example, change the shard key in a document. Right? So you can actually go ahead and you never have to change the shard key before. You'd have to actually remove the document, put it in somewhere else. Now you can actually do that. And under the covers, it's just going to use a transaction to make that happen completely seamlessly. If you want to learn more about how and when to use multi-document asset transactions, you should check out Ali's talk a little bit later today, right after lunch. So transactions are pretty cool. We're very excited about them. If you haven't tried them, please go check them out. And of course, transactions are really interesting in isolation. But what happens when you join them with $lookup? Come on, guys. Someone must have thought that was funny. No? Whatever. So for those who don't know, $lookup is how you do joins in MongoDB. Right? It's the aggregation pipeline stage that lets you join data in two collections together. So given that we now have joins, and joins came out a few years ago, but we have joins and we have transactions, it really is pretty clear that MongoDB is the best database for relationships. So why is that? Well, traditional databases have one way of modeling relationships, right? And that is by reference, right? You can have an order, and you can have inventory, and you have them by reference, right? This is the standard way you've been doing everything in a relational database forever. Right, you use foreign keys and joins and transactions in order to maintain these relationships between different rows. But in MongoDB, you can do this as well. And with transactions and joins, this works quite well. But in addition, you can have embedded relationships. Right? You can have line items embedded into order. You can have a list of addresses embedded into a user. You can have a list of likes embedded into a user. And so we really have two ways of managing relationships as opposed to one. And it really is as simple as that, because having two is better than having one. But it makes the ability to model data in a much more intuitive way really incredibly easy for developers. And that is really at the heart of what makes MongoDB so powerful. So that's transactions. Please check them out. We'd love feedback, and as we're continuing to sort of work on sharded transactions. and as people are starting to adopt 4.0. So please check them out and give us as much feedback as you can. So documents are great, and documents are pretty intuitive, right? So this is an example of a document. It is an entry in a product catalog, and it's a pretty simple way to look at data, right? As we said, one of the great things about documents is that they're intuitive, right? You can go ahead and look at this document. You can see the embedded things. There's no like keys to go reference. You can just sort of see all the attributes about this product right here, and that's pretty great. But what happens if you want to actually go and there's some production issue at 3 in the morning and you need to fix that URL right now? Trying to construct the right update statement, whether you're in a SQL or not, or in the Mongo query language, is kind of challenging. And so a few years ago, we introduced Compass. And Compass is a tool that, one of the things it lets you do is actually go and work with the data in a GUI to make it really easy to work with and edit your data. So that's pretty nice. So what we wanted to do this year was actually bring that same functionality directly into MongoDB Atlas. For those of you who don't know, and hopefully you all do, MongoDB Atlas is our fully hosted database as a service for MongoDB. It runs on all the 3 major public clouds. So no matter where you are, you've got the great experience. We'll come back to this a little bit later. And we've actually brought that same CRUD experience directly into the Atlas UI. So now if you're using Atlas, you can just go to the UI and look at your data, run queries, edit your data, insert data, work with it all from the Atlas UI. And actually yesterday, we released the Data Explorer for not just regular Atlas clusters, but for the free tier in Atlas and the other shared tiers in Atlas. So no matter what Atlas clusters you're using, now you get the same great Data Explorer experience. So we've got documents. And the next thing you want to do is go and do some analysis of that data, maybe do some aggregations. So the way you do that in MongoDB is by using the aggregation framework. So the aggregation framework is really based off one of my favorite things in the computing world, which is the Unix pipeline. So this is a Unix pipeline. It is one of my favorites. I do have a list. It's kind of sad, but I do. So this one, if you haven't figured it out by now, looks through a MongoDB log file, finds the latency measurements for all the operations, sorts them, and spits out the slowest 20 operations in that MongoDB log file so you can go and add indexes, things like that. Pretty straightforward. And what makes the Unix pipeline so powerful is that it's a bunch of little programs that you can combine together and debug and compose in interesting ways. And the aggregation pipeline is exactly the same thing. You can compose different stages together in interesting ways and do really powerful things. It's really easy to debug because you can chop things up in half and move them around, things like that. Like if you've got a 20-stage pipeline, you can do a binary search to find the bug. And it's very powerful. So we've improved it in a bunch of ways in 4.0. The first is we've added a lot of date manipulation. So you can construct dates, deconstruct dates, use time zones, lots of stuff with dates. And of course, once you do that, you want to be able to construct things out of strings and do things with strings. So we've added a lot more string manipulation operators. Turns out what most programmers do is just manipulate strings. So it's kind of useful. And third, a lot of typecasting. So you can do typecasting from strings to numbers, or numbers to strings, or dates to numbers, or kind of whatever you want. So here's that same sort of pipeline in MongoDB, right? You've got your logs, you're going to sort them, you're going to do a limit, you're going to do a group. This is a pretty straightforward aggregation query, right, in Mongo. 3 stages, a sort, a limit, and a group. All very straightforward. But what happens if you've got a really complicated one? What happens if you've got 20 stages? So you can go and use binary search and go break it up and use some code, and you can make it work pretty well. But we thought we could do better. So in the newest version of Compass, we've got a new feature called the Aggregation Pipeline Builder. And what that does is it lets you visually build an aggregation pipeline. So you build your stages on the left. Right, so this is, the first stage is a filter, and it says only show me documents where status is completed. And on the right, it shows you the output after that stage. And then you can go and add more stages. Right, so now we're adding an unwind stage and a group stage. And every time you add a stage, it's going to show you the output at that point. So now you can go and edit your aggregation pipeline in real time, edit the left-hand side, and every time you do, the right-hand side updates, so you can have an incredibly easy way to debug your pipelines. And to show you just how easy it is to use the Aggregation Pipeline Builder to build and debug interesting aggregation pipelines, I'd like to invite Asya to give you a demo.
Good morning. Thank you, Eliot. Last year at MongoDB World, right here in Chicago, I gave a talk about how incredibly powerful aggregation pipeline is and how you can build complex analytics of your data right where it already lives in MongoDB. The best way to do that is iteratively, stage by stage. And I'm very happy to show you today how much easier it is with Compass Aggregation Builder, whether you're an experienced user of MongoDB or a novice. Here you see your basic Compass, and I'm in the Aggregations tab. I'm going to show you first how to build a brand new pipeline. And that's simply by selecting a stage that you want to start with. Now, the nice thing here is it shows you all possible stages. When you start typing the name of a stage, it narrows it down to the ones that match. And because I have comment mode on, when I select a stage, what it shows me is all the different fields that that stage expects, which ones are optional, which ones are required, and what each one of them means. If I just wanted to do a simple grouping, let's say I wanted to group by category, you have automatically fields being suggested for me. And then I'm going to just say, OK, I'm going to find out average stars. There's my average accumulator, and from actual stars. And as soon as I finished typing, it showed me that for each category, here's the average review score. Well, that's pretty cool and simple. But I might want to do a much more complex pipeline. In fact, I was working on one earlier, but I didn't get a chance to finish debugging it. What I was doing is I was trying to analyze total revenue and slice and dice it by state, by year, month, by category. And there's a great new feature in Compass that allows you to import the text representing that pipeline from somewhere else. So whether you're working in the shell or in your favorite editor, we're just going to go here. We're going to select this text. We're going to paste it. And here's the pipeline. So these are our original documents, right? All good pipelines start with a match, narrowing things down to only completed, unwinding the array products, and then grouping by various things I'd already mentioned, the user state, the date created, but just the year-month portion of it, right, the category, and then doing summing of the quantity sold, total revenue, and then grouping it again by state and year-month, getting that total revenue rolled up. Except here, I suddenly noticed that my year-month doesn't look correct here, right? It's correct in some of the documents, but not all of them. So I can back up and look at my original data and realize that date created sometimes is an ISO date, but other times it looks to be a number, and it looks like it's number of seconds since epoch. Luckily, I'm running this against MongoDB 4.0, so I have all those date and type conversions that Eliot mentioned. So all I have to do is add a new field. Now, I'm going to call it date created so that I don't have to change any of the rest of my pipeline. And I'm going to use a type conversion. When I type to, it shows me all of the available ones. There's to date from, again, date created. Immediately, it shows me, see how both of them are now dates. Scrolling further down, there you go. My grouping's been fixed. Now there's the rest of my pipeline. Now, if I want to save it, I actually want to insert it into my application code. And what we have here is the ability to export to a language. You can see that optionally, I can even tell it to include all the import statements I might need. For some languages, it shows me different ways that I could structure the code. And even though I might know how to do it in my language, this is going to save me a lot of typing, right? Just copy this and paste it over somewhere else. All of this is available to download right now, so please download Compass and see how its intuitive workflow and real-time feedback can really help you build more powerful aggregations and analytics of your data. Back to you, Eliot.
Thanks, Asya. I don't know, but I think one of the coolest things about some of the new stuff, besides the fact that you can just do the debugging in real time, the ability to actually just copy your Java code and put it into this thing and have it figure out what you meant is kind of cool. Anyway, this is one of my favorite new features in MongoDB 4.0, actually, because the number of times over the last 7 years I've been trying to debug pipelines, and I've done this myself manually. This just makes life quite a bit easier. As we said, this came out in MongoDB 4.0, so it's out now. Go check it out and go try it. So we've talked a little bit about MQL and the Mongo query language and how great it is for querying documents, for analyzing documents, for filtering documents. And it's great for a number of reasons. One of them is that it's programmatic. Right? If you want to add predicates and add filters, you're not concatenating strings together. You're dynamically writing queries because it's a programming language. It's easy to build programmatically. But sometimes you want to do that, but you're sort of stuck. And your users maybe are using a mobile phone or a browser, and your data's in Mongo, and then you've got to build a layer in between to sort of translate what's going on. So let's look through an example to really make that pretty clear. So let's imagine we're going to build a little e-commerce site. So we've got a list of products in the bottom right-hand corner. We've got a REST API call, and then we have the corresponding Mongo query. Right? You can all imagine this architecture. I've got a UI. I want to make a REST API call that I'm going to construct. I'm going to construct the REST API call in my JavaScript code, and that's going to turn and call some app server thing, which is going to construct some Mongo query. All pretty straightforward. Great. So now let's go ahead and add some filtering. So the first thing we're going to do is add a category filter, right, where you can go and select filter. So now I'm going to, in my URL, I'm going to add a category equals shirts filter. I'm going to write some code to convert that into a query and do all the sort of sanity checking and injection kind of checking for injection attacks, things like that. Pretty straightforward. You can all imagine writing this in a few minutes. Okay. Now we're going to add another filter. Now we want to do by brands. Okay, same thing. In my application code, I'm going to check for if I've got a category filter, if I've got a brand filter, then go add that predicate to the query. It's all pretty straightforward. It's going to make it a little bit more complicated. Right now I want price. So I've got a min and a max. So now I've got a piece apart that, if there's a price, if there's a price min parameter in my URL, go pull that out into a price, doing like a price.lt, all relatively straightforward. But you're maintaining this code is kind of annoying, and what if I've got 100 of these things instead of 3? All right, let's keep going. So now I want to order, and ordering is a little bit annoying because ordering you've got to sort by what you want to sort by and the direction you want to sort. And then you've got to okay, is it ascending or is it -1 or is it 1 or what do I want to do and how do I make this work? And it's all fine, but it's getting a little bit annoying. And what happens if you actually want to sort by 2 things? What if you want to sort by price and rating or rating and price? Now I've got sort 1, sort 2, rating 1, sort 1, order 1, sort 2, order 2. It's getting pretty messy. And you can imagine in a real world example, this can get way more complicated. Right? As you want to have sort of more filtering and more analysis and more things, you're basically doing a lot of work here. And what you've done is you've got this nice query language that you can build dynamically on one side. You're building basically an API. You're basically building a query language in your REST API, right? That basically is a query language. And frankly, you're building another query language, and it's not a great query language. It's kind of a shitty query language. You can call it SQL if you want. And wouldn't it be much better if you could just build that Mongo query directly in the browser or directly on your mobile application and send that query directly from your browser directly to the database? So it sounds kind of crazy. It's well, you can't because it needs security and all these things to make it actually safe. Well, that's what one of our new products called Stitch Query Anywhere is all about. Stitch Query Anywhere is designed so you can write a query anywhere and run it directly in Mongo. So it looks something like this, right? You've got your browser or your mobile phone. It would generate a query there. It would go through the sort of native SDK that we have either for JavaScript or iOS or Android. It would then go to Stitch. It would go through an authentication system there. It'll go through a rules engine, which I'll come back to in a second, and go directly to Atlas. So you can actually just build those queries up dynamically in your application and send them to the database. They can be aggregations. They can be, they can be regular queries. They can be aggregations, anything you want. So what is Stitch Query Anywhere? Well, first, it has the full MongoDB query language. So anything you can do in a regular Mongo query or in the aggregation pipeline, you can run through this. Second, so authentication is built in. So you authenticate to the Stitch service using either some sort of custom auth plugins. You can use Google OAuth or Facebook OAuth or Twitter or any sort of OAuth provider. You can use sort of your own custom usernames and passwords, or anything you want. You can sort of have a way of authenticating your users directly to the Stitch service. And at the heart of it is this set of declarative rules. And the rules are on a per document, per user basis. This is the interesting, tricky bit, right? When a user does a query, for every document that person is going to look at or try to modify, a different rule is applied based on that user and that document, right? I can actually look at the fields in that document and that user to understand what they can do. So let's look through a quick example. So let's imagine you're trying to build a medical application on top of MongoDB and Stitch. So there's 4 roles we're going to talk about. So the 4 roles we're going to talk about are, one, a patient role, a doctor role, a nurse role, and an insurer role. So how do you get mapped to a role? So when you do a query, for every document that might be returned by that query, it's going to try to figure out what role you are. And it can be different for every document in a result set. So the first one, the patient role. The patient role is going to have a rule that says, if the patient ID matches my user ID, I'm the patient. Straightforward. The second one, the doctor role. If my user ID is in the list of doctors, then I get the doctor role. Nurse role, same thing. If my user ID is in the nurse role, I'm a nurse. Insurance agent. Maybe it's my user ID is in the list of insurance agents, or maybe it's my company organization. My email domain name is in the list of insurance companies involved in this case. I get the insurance role. If I don't get mapped to any roles, then I don't get to see that document at all. It just doesn't exist. And then once you get mapped to a role, you can do different things. So down the left-hand side, you see fields. Right? So basic info, things like address, email address, first name, last name. Diagnostic codes is sort of like whatever those codes are that doctors give to insurance agents that no one here understands. Well, probably someone does, but I don't. Then you've got notes, like these are the actual doctor's notes. Then you've got prescriptions, and then vital information, like blood pressure, height, and weight. So then for each one of these roles and fields, you just have to say what you want. So for a patient can read everything. But the only thing they can modify directly is their basic info, right? They can go ahead and change their address, but they can't go and write themselves a prescription. A doctor can read everything again, but can only write diagnostic codes, notes, and prescriptions. A nurse can read everything, but can only write vitals. The insurance agent can only read the basic info and diagnostic codes and can't see anything else. And obviously, you can just make these as complicated as you want and deconstruct these. You can actually make the rules very complicated. But this way, now let's say that you're a third-party application. You've got your data, and you would like someone to let you do some graphs of your weight over time. You don't have to make a REST API call to do that, right? So you don't have to make a custom REST API call to do that, where you're like sorting the history over time. No, you just go ahead and do a query. Like, okay, find me do a query for this patient and the aggregation. And the database is doing the aggregation just like it would normally. So you want to do more complex analysis. You just have to write the aggregation framework as you would. You're not writing a custom API for every time someone wants to do analysis. And what's even more important is that what happens today is since people don't write custom API calls for every analysis they want to do, what actually happens? Well, people actually just take the data and make a copy of it, and then have a copy of that data that they leave somewhere, that they leave unsecured, that's out of sync, they have to build synchronization for and security around it, because you're basically just creating multiple copies for every time you want to do analysis, because getting actually at the core data is too hard. So this makes that a lot easier, just to either both build applications on the top of it and to actually do interesting things with that data. So Stitch Query Anywhere GA'd in MongoDB around MongoDB 4.0, and it is one of the 4 services of part of MongoDB Stitch. So what is MongoDB Stitch? So Stitch is a serverless platform for building modern applications, and we'll talk about the rest of the pieces a little bit later. But Query Anywhere is all about letting you get access to your data safely and securely from any device without having to write a ton of middleware. Right? Because that middleware tends to be just about security and privacy and some sanity checking that frankly can be done as a set of rules, making it way easier to build applications. So we've got our documents. We've got access to them. We're building applications. I've got an application that's successful. So the next thing that happens is I've got business users who want to get more insight out of that data. And for that, we've built a number of different tools over the years to enable sort of BI operations. So a few years ago, we introduced the BI connector. What the BI connector does is give a read-only SQL view into Mongo. So you can connect tools like Tableau or Click or MicroStrategy directly to Mongo. It will flatten your documents out and frankly making them a little bit ugly, but it works. That way you can use Tableau or any other tool that you're used to and just work directly off your data sitting in Mongo. This year we actually introduced an ODBC driver. And this one's pretty cool because now if you're an Atlas or anywhere, you can go ahead and install the BI connector in Atlas. It's one click. Then go and install the ODBC driver on your laptop and connect Microsoft Excel to Atlas in a matter of minutes. And this is pretty cool because most data analysis is frankly done in Excel, not in any other tool. And now you can actually just bring that data from Atlas into Excel incredibly easily and just write SQL queries there and bring them straight into Excel. So that's pretty fun. And also, we now have a new thing called MongoDB Charts. MongoDB Charts is a native BI tool for MongoDB. So it has a native MongoDB UI where you can actually go ahead and build charts interactively. Right? It's drag and drop. You can go play with them. There's a lot of different chart types in there. You can then go take those charts and turn them into dashboards that you can share and put on a screen. And so MongoDB Charts, the beta for MongoDB Charts went public in June. So if you'd like to go check that out, you can check it out, give it a try. We'd love to get feedback on that as you start playing with it and as you can start building cool charts. So that's the document model and what we've done in 4.0 to make it better. We've got ACID transactions and replica sets on 4.0 and sharded clusters in 4.2. We've got full CRUD support directly in the Atlas UI. The aggregation pipeline builder in Compass, Stitch Query Anywhere, and lots of tools for doing analytics. So lots of great stuff in the document model that we've improved upon. So next, we're going to talk about distributed systems. So distributed systems, as a quick recap from earlier, right, it's how you get high availability in MongoDB, how you get scale out, how you get workload isolation, and how you can use zone sharding. And so we're going to dig into zone sharding a little bit right now. So why is zone sharding important? Well, one is latency. So if you ever go to Australia, which I encourage you to do, it's a fun place to visit, everyone you talk to there says every time they try to use a startup that's based in the US, the user experience is terrible. Why? Because most people just spin up their data center that's probably, frankly, in US East 1 and Amazon. And the latency from Sydney to Virginia is like, 300 milliseconds for every call. And as apps become more and more interactive, or every time you drag something on a screen, it's making some database call, which is taking forever. So user experience from Australia is terrible. So it'd be great if you can keep data for Australian users local, or have a read-only copy of the shared data local. So you're not going across, all the way from Australia to to Virginia for every database query. 2 is regulation. Right? The number of laws that are being created all the time that says where a certain data has to live are only going up. Right? In Germany, all German citizen data has to be in Germany. The same thing's starting to happen in Australia. It's happening in the EU in many places. It's happening in Japan. It's only going to go up. And as developers, you need to comply with laws. You need to sort of ensure users' privacy. But at the same time, you don't want to have to do a lot of work to actually go ahead and spin up different clusters in every place and then go figure out how to merge data and do all this sort of complex stuff. Because now you've got to do your own sharding, your own data isolation, and then you want to do analytics on this data. And now how do I do analytics across 20 different clusters since I can't actually merge the data in one physical location? And that's what zone sharding in MongoDB is all about. Right, so with zone sharding, you can put different data in different places. So you can start off with one data center in the east coast of the US. You can add a second data center in Europe. And what's going to happen when you add that data center is you're going to tag your documents. So the documents might have a location code. That location will be like US-IL or US-NY. And then you'll say everything that starts with US-NY should go to this data center. Then you'll say, OK, everything that's EU-DE should go to this data center, so on and so forth. And you can just control this mapping so that different documents go to different physical locations. Now, in this, for now, we've got people in Australia probably going to our EU data center, right? So if you're an AU dash, or just AU, I can't remember. It's AU-SY, I'm making this up. Then it would map to the European data center. But now let's say you really care about Australia. So what do? You go ahead and add an Australia data center. And you basically just you change the configuration so that documents that used to go to Europe now go to Australia. Right? You're not changing the data in any way. You're just changing the metadata of the cluster. Or you've added a new zone. You're changing the metadata of the cluster. And what's going to happen is seamlessly in the background, all the data for the Australian users or other Southeast Asian users are going to slowly move to Australia. And then it's going to have a much better user experience. And it's all going to happen under the covers through the power of zone sharding. So this is a pretty cool building block. But you still got to go and manage this cluster. It's a big cluster, a lot of machines. You got to figure out what it does. You got to figure out the right mapping. Okay, you know, if I'm in China, do I go to the European data center or the Australian data center, and make a lot of decisions? So we thought it'd be really great if we just made this all go away and just built this directly into Atlas so you can do this incredibly easily. And so in Atlas now, you actually have this exact experience, right? You can go build a global multi-region zone sharded cluster in a matter of minutes, manipulate it, manage it, add more zones, and everything else you need to do is fully covered for you, right? It's all managed, the security is all the same, and all the mappings about where things should go based on latency, we figured out all for you. And to show you just how easy that is, I'd like to invite Austin to come give you a demo of Atlas Global Clusters.
Thanks, Eliot. Hello, Chicago. Man, it's a good-looking group. All right, so let's set a little bit of context here. We are in the Atlas console, right? And so this is where you would be controlling your Atlas instances. And all of this functionality is buried under the build new cluster, right? So before we introduce the global cluster configurator, you could come in here, you could add a cluster on any of the cloud providers, Azure, GCP, AWS. You could pick the zone you wanted to be in. You could add extra regions, et cetera. So all that functionality is still there. You can still build all these things manually. But what's really cool is that we've added now this really beautiful UI, this interactive interface, that allows us to understand what the latency for our global cluster would be, right? So when Eliot was talking about the experience for folks in Australia, we can absolutely see, right, when we take a look, Zone 1, North Virginia, it's really bright, right? And bright is good. Bright is low latency. But as we get darker out, that means that we have less latency. What this tool is going to allow you to do is to build a global cluster. Right? Now you can build this yourself, or you can use some templates that we've created to help you get started, and then you can use that as a jumping off place. So let's go ahead and take a look at that. To enable this, I just click the on button. Again, we can still do this across all three of the cloud providers. And we've got a couple of starter templates. You can modify these. Let's go ahead and take a look at the global performance one. What the global performance template gives us is a complete, sun never sets global cluster. So we've got something in the North America, we've got something in EMEA, and we've got something in APAC, right? And we can tell by clicking on those clusters what the latency is for each one of those data centers. But let's say that the one that we have in EMEA, we don't want it in Frankfurt, we want to have that in London. Right? Well, that's very easy to tweak. All we have to do is come down, pick which zone we're dealing with, and then change to London. And as we do that, the map will interactively change with us. Okay. So this is good. This is good latency, but we can absolutely do better. So let's take a look at the excellent global performance. And now we have a much brighter world. Right? Because we've added more zones, we've added more regions, we've got more data centers involved. In some cases, we have areas that have multiple data centers. We have a complete zone, a complete global data cluster all around the world here. But let's take a step back and talk about, how's this really working behind the scenes, right? As Eliot said, there's a lot of complexity there, there's a lot of servers. How do we get data to the right place? Well, it all comes down to leveraging the concept of ISO codes and subtype codes and embedding that in your data. Right? So the concept of location. Your data can originate from anywhere, right? Data belongs conceptually to different areas. But leveraging Atlas, you can route the physical documents to wherever you want or need them to be stored, right? So let's take a look at how all that kind of comes together. Now the first question is, isn't this complicated to manage? And the answer is no. You manage it exactly as you would any other Atlas cluster, because that's exactly what it is. And from your developer standpoint, all that they need to do is to include this connect string in their application. And no matter how simple or complicated your global cluster is, your application will be able to route and talk to your data, right? So no matter what changes, this is all you really need to include in your application. Now the real devil's in the details, and the details is in the data. So let's take a look. This is our data inspector, right, in Atlas. And we can really see all of this coming together when we take a look at what happens when we have a global cluster and we're creating a database. So I'm just going to give it a little hello world tag there. And what I really want to call out is the shard key. So in this particular case, there's a couple of parts that come together to form the shard key. And the first one we're defaulting for you. We're calling it location. That is where you're going to put that ISO code or that ISO subtype code that will ultimately tell Atlas where to route your data. And then the other part of your key is just whatever is relevant for your application, in my case, customer ID. So if we take a look at some data that we already have in here, we see there's our customer ID. But that location is indicating both, it could be where the data is coming from or where I want it to be stored. It's completely up to you. But that location field is going to be leveraged by Atlas to make sure that the data gets routed to the appropriate data center. Okay? So if we come back around to our global cluster here, right, we see, look, we've got really good coverage, but let's say that our business plans change. And instead of where we're at now, we now want to move into India. So we can take a look and we can see our latency. Well, EMEA is not really giving us very good coverage there. And APAC's giving us some, but that's pretty dark. We'd like to do better. So what we're going to do is we're going to add a zone right there in Mumbai. And we now see that our users in Mumbai and in the Indian region and in that entire zone are going to get great low latency, right? So as your business changes, you're able to adopt and change how this global cluster works. Now this is great for writes, but if you want to have low latency reads as well, all we have to do is click this configure local reads in all zones. And we now have a truly global data cluster. So leveraging this tool, you'll be able to reach all 4 billion internet users. Thank you very much, Eliot.
Thanks, Austin. So you see just how easy it is to build and manage these really interesting global clusters and have great latencies for every user, no matter where they are on the planet. And we think that's really important. And so that is available in Atlas today. Go check it out. Go try it. Turn your application into a, supercharge your application, and do great things. So if you want to learn more about how to build these, how to manage them, and how they work under the covers, you should check out Andrew's talk a little later this afternoon about global clusters in Atlas. So one of the interesting features that we released in MongoDB 3.6 last December was change streams. And change streams are how you can get real-time notifications out of MongoDB to do other things. So for example, maybe you want to, every time you update something in MongoDB, put something into Kafka, or update some other downstream system, or whatever you want. And change streams are pretty easy to use and pretty powerful, and they look kind of like this. You're going to subscribe to a collection and say, I want to get notified of every time, and in this example, every time an insert or a replace happens on that collection. I only want to know when n is greater than or equal to 1 in this case. And then I'm just going to loop over that change stream forever and do things. So this is pretty easy and it's pretty powerful. There is a bunch of other work you have to do, though. You have to make sure the system's running 24/7. So change streams have resume tokens so that you can resume from where you left off. So you've got to store that resume token somewhere safely and manage that. You've got to manage high availability for this cluster. And we thought we could do better. Right? We thought that there's a better way to make this even easier for you in MongoDB. So we've introduced a new tool called stitch triggers. And triggers really are triggers that you'd come to expect, but redesigned for a modern distributed environment. So what does it look like? Well, triggers are combined with stitch functions, right? Another stitch service. And stitch functions is a serverless JavaScript environment where you can write tiny little JavaScript programs and you run them all completely serverlessly in a fully managed environment. So how do these things combine together? So let's imagine that you've got you're incrementing a counter in MongoDB. What happens is that that is going to get noticed by a stitch trigger. Right? A stitch trigger is going to pick up that change. That stitch trigger is going to call a JavaScript function that you write. That JavaScript function is going to do whatever you want. For example, it's going to go ahead and call a Twilio API call, which is going to make someone's phone go ding. So I think the best way to really understand what a stitch trigger is and how easy it is to use is to give you a demo. So I'd like to invite Blake to come up here and give you a quick demo of stitch triggers.
All right, good morning, everyone, and thanks, Eliot. So to get started, what I want to do is walk you through an example of how you can leverage Stitch, which is our serverless platform, to enable real-time decisions and actions within your applications. So what we're looking at here is that new data explorer that Eliot just spoke about. It's going to give us insight into the collection. For our example, I'm going to leverage the products collection, and I want to get a good understanding of the types of documents we're going to be working for. Because in this example, what I'm going to do is send an email notification to an administrator when a product's inventory level dips below a specified amount. Okay, so we see there's a handful of products out here, and here's an inventory field. So we're going to use this inventory field when we define our trigger. Defining the trigger is very straightforward. All I have to do is tell Stitch which collection to watch and the function to execute. So let's go ahead and configure that right now. For this example, we're going to monitor the products collection, and I want to tell Stitch which operations to watch. I don't want it to have to take action on every single database operation. I want to be very prescriptive. So for this example, we're going to say grab the update and replace. The next thing we'll need is when I construct my email, I want to use that document that was updated to actually build out that email to the administrator to let them know. So we're going to have it return back the full document. And to make this trigger even more performant, I can define a match expression to refine when this trigger actually executes. So in this example, when the product's inventory level is less than 20, we'll then call out the send low inventory notification function. Taking a look at how that function's created, we see that there's a product event. So this was actually the change that was captured. And from that product event, I can get access to the updated product document. And we're going to use that product document to construct the email, which is what we're doing right here. So I'm going to grab the product name, the product ID, and the inventory level. The last thing I need to do in here is I actually want it to send that email out. And I'm going to leverage a service from AWS, the simple email service, to do that for us. Within MongoDB Stitch, there are many built-in service integrations. In this example, we're going to leverage the service from AWS. So to do that, I have to provide my AWS access and secret keys. And then we're going to go over and configure the rule. So before I configure this rule, I'm not just limited to AWS SCS function. I actually have access to a wide variety of services in the AWS catalog. But for this example, because we want to send out that email, I'm going to create the rule that says when this condition is true, we're going to go ahead and enable the SCS send email API. Okay? So now that everything's configured, we've set up the trigger, configured the integration, wrote a little bit of JavaScript code to actually build out that email. Now what I'll do is I'm going to go ahead and simulate an order. All right, so we're going to go back to the Data Explorer, and I want to look for a product that has an inventory level right around that low threshold of 20. So we'll say where it's less than 23. And here we go. We have the ever popular baby onesie. And we see that the inventory level is currently at 21. So to simulate the order, I'm going to go ahead and update this to 18 because every baby makes a lot of messes, and we probably want to have quite a few onesies on hand. We'll go ahead and hit update. So if everything's configured correctly and the demo gods are looking upon us favorably, I should see an email pop into that administrator's inbox because we've set up the rule to say watch for inventory items that fall less than 21. All right, so let's take a look. And there it is, right? So the administrator just received this email alerting them that that baby onesie is in fact the inventory level is at 18, which is below our threshold, and we should probably look to reorder new inventory soon. So in conclusion, MongoDB Stitch triggers makes it incredibly easy to build real-time services without spinning up any infrastructure or middleware. In a matter of a few minutes, I configured the trigger, set up an integration to a third-party service, and with a few lines of JavaScript, I was actually able to build that email using that updated product document, and then send the email based on that business rule. So with that, I want to thank everyone, and I'll turn it back over to Eliot.
Thanks, Blake. It really is incredibly easy to set one of these things up. I've got a couple of Stitch apps that I use that I make other Mongo employees use because that's kind of fun. And it takes literally like minutes to set up triggers. I had one set up the other day because every time someone, anyway, I rebuilt our HR system on Stitch. It's a long story. But so anyone like requests times off and it goes over a certain threshold, it emails their VP. It's a whole thing. It took like 3 minutes to set up. It's actually quite cool. And there's a lot of things you can do with it. For example, you can, every time a event happens, you can update some analytic system that has some data in it. Maybe you want to, every time a document gets inserted, send an email, or if in some conditions, send an email or a text message or something else. Maybe every change, every new document, you just want to send that event to Kinesis or to Kafka or to any other sort of queuing service to trigger any other kind of queuing thing. So that you don't have to sort of dual write from your application. You can just insert your data in the database and then trigger any downstream changes that need to happen. Or maybe you simply, every time you insert a document into Mongo or update a document, you want to update some other Mongo collection, right? I've actually got a Stitch trigger in the same thing that every time a new hire gets entered into the system, it goes and computes some stats about that person and goes and updates that document just to decouple some of the application code so the application code that just writes to the database doesn't have to know about this other stuff. And then a trigger comes back along and cleans it up. Right? Lots of very cool stuff you could do with Stitch triggers, all incredibly easily if you're an Atlas. This went out in GA in 4.0 in June. If you haven't tried it, go check it out. And if you're not an Atlas, you should be an Atlas anyway, and it's really easy to get in there. Another quick note about Stitch, now that we're sort of tying this all together slowly. So both Stitch and Atlas have a pretty generous free tier. And now with the Data Explorer also, now that that also works in the Atlas free tier, you're now sort of like free tier experience with Atlas and Stitch, and the Data Explorer makes it incredibly quickly to go out and iterate and build really cool applications very interestingly and sort of explore everything. If you want to learn more about Stitch triggers and how you can do really cool stuff with that, you should go check out Mike's talk a little bit later this afternoon all about triggers. So that's distributed systems, right? We've talked about global clusters and Atlas. You talked about Stitch triggers. Lots of cool stuff there. If you haven't tried them, please do. So the last thing we're going to talk about today is how you can run MongoDB anywhere, right? We've talked a lot about this before and how it's important that no matter where you are, you get the same MongoDB experience. So one of the things that we're working on right now that's not quite ready is the ability in Atlas to actually have clusters that not only span different regions, either for reads or for writes, but to actually span different clouds. Right? So you'll be able to have one logical cluster that is in as many of the public clouds as you want. So why might you want that? One is for lock-in, right? When we release cross-cloud, you'll be able to go from one cloud to the other very quickly. Right? You'll be able to even spin up some secondaries in one cloud, test it out, maybe try it out as your primary region for a little while, then go back and mix and match and sort of, so you have really a lot of flexibility. Right? Moving clouds, the biggest challenge with moving clouds is not like bringing up new app servers. It's getting the data there and setting up all the data access and all that other stuff. And with cross-cloud Atlas, it'll be incredibly easy. Maybe you're in one cloud and you're very happy, but you've got some requirements where you have to be in certain regions. Right? Now you're kind of stuck. With cross-cloud clusters, maybe you can actually do that. So you've got 10 different regions. You really need to be in an 11th region, and the cloud provider that you're using currently doesn't have a data center in that region. No problem. You just spin up that 11th region in a different cloud provider. Maybe you need to have 3 different regions inside of a certain country, right? You need 3 zones inside of Germany. Amazon only has 2. Great, you spin up a 3rd one in Google. Super simple. Or maybe you want to do something a little bit different. Maybe you're very happy with, with Microsoft, and you've got all your stuff in Azure, but you really want to use Google's TensorFlow service. So what you can actually do is spin up some secondaries that live in Google, so that when you want to do machine learning algorithms off that data, they don't have to go over the network to actually pull the data over every single time, because only the synchronization happens over the wire, and when you're actually doing the actual full machine learning, everything's staying right inside Google. So that makes that quite a bit easier. So that's pretty nice. And that's coming a little bit later. So the public cloud's great, and Atlas is great, but for a lot of people, they can't be in the public cloud for either regulatory reasons or historical reasons. But it's clear that everyone who's in their own data centers wants an experience that is kind of like the public cloud. Or they want sort of a private cloud experience that is as close to public cloud as possible. And the clear winner in that space, at least to us, is Kubernetes. Whether you're using vanilla Kubernetes or any of the other packaged versions of Kubernetes, that is by far the most popular thing today to build private cloud experiences. So in MongoDB 4.0, we released a beta of our Kubernetes integration. And what that does is it's basically a Kubernetes operator that lets you run regular Kubernetes operations commands using the regular Kubernetes tool. It will then go drive Ops Manager. And Ops Manager will actually be the thing that manages and monitors and backs up your MongoDB clusters, but it's a completely Kubernetes-like experience for all of your developers and administrators. So they can go figure different sizes, right? You can set up a small, medium, and large Mongo cluster. Your developers just say what size cluster they want. The administrators get to choose what that means, and then Ops Manager goes and manages it for you all through Kubernetes. The beta for that went out in June. Please check it out if you want to use Kubernetes. It is, and we're working towards the GA on that. So one of our goals here really is that you can run MongoDB anywhere, right? So there's a couple places, really one place that it's been kind of impossible to date. So here's some Java code. It's a pretty generic Java code, does some MongoDB stuff. It's a barcode reader that increments a count whenever it sees a new barcode. And this is standard Java code that you can imagine running on any Java app server. But where do you tend to read barcodes? You tend to read barcodes on your phone. Whereas you take your phone, you scan on a barcode, maybe you're like in a warehouse. So wouldn't it be cool if you could take this Java code and just run it on your phone and store the data locally? So MongoDB 4.0 also includes a beta of MongoDB Mobile. And MongoDB Mobile is exactly what it sounds like. It's a mobile version of MongoDB that runs on iOS or Android phones where you can actually have the full Mongo experience directly on your phone. Right, no sharding or no replication, but the full developer language, all the query language, everything else directly on the phone, which is kind of cool. Right, so now you can, maybe you're pulling JSON data over some REST API call. Now instead of having to take that JSON data and store it some other way, you can actually take that JSON data from the API call, store it directly in Mongo locally, and now use the Mongo query language to work with that data. You can write it locally, do things like that. So that's pretty nice in and of itself, right? Now you can have a full document database directly on your phone. But I don't think a mobile solution is really complete without some sort of synchronization story. So the 4th Stitch service that we're going to talk about this morning is Stitch Mobile Sync. Right? Stitch Mobile Sync is kind of exactly what it sounds like. It is a service that synchronizes a subset of your data from your Atlas cluster directly to your phone. So the developer inside of your application on your phone is going to call a couple of operations. So they're going to call the sync method on a collection. You're going to say which documents you want to synchronize. You're going to give it a conflict resolver. So that conflict resolver actually lives on your phone. So if you've written to your phone and someone else has written, you're going to get both versions of the document on your phone. You can have a very simple automated algorithm that just says last write wins or higher number wins, whatever you want. Or since you're on a phone, you can actually ask the user, hey, Bob did this and you did this. What's the right answer? So you've got a lot of choices, and you can resolve the conflicts on your phone, and then your phone will go send that result back up to the server. And then you've got an event listener where you can go ahead and listen to events that are happening and do other things. So what's this going to look like? It's going to look like this. So you're going to have an Atlas cluster. Stitch is going to be using change streams to pull changes out of there. As things change, it's going to push those changes directly down into the phone, right, in a real-time basis. So it's going to, it'll be an SDK there that'll be pulling these events. It'll store them in MongoDB, can send them to your application, and so your application can query that local MongoDB. So it's super simple. So imagine you're building some sort of CMS where you want to be able to actually edit documents on your phone. So you can do things online or offline, right? So that works when you're on an airplane. Right? You're building some note editing software or a to-do list, sort of anything else. You can actually just edit your data directly on your phone or your iPad, do it offline. When you get back service, it'll synchronize. Maybe you just want really low latency and you've got a lot of documents and you don't want to have to make a network call for every single thing a user wants to do and just, you want clicks to be really fast. And they can just cache that data there, but if someone else is editing the data or something else changes in the back end, it gets updated in real time on your phone. This is in private beta at the moment. The public beta will be pretty soon. So if you're interested, please let us know. And if you want to learn all about MongoDB Mobile and what we're doing there, please go check out Matt's talk a little bit later this afternoon. So 3 really cool things in letting you run MongoDB anywhere. Cross-cloud coming a little bit later. The Kubernetes integration, so you can go start playing with that right away. And then mobile sync. So we've talked about a lot of cool stuff this morning around how we've made MongoDB even better in 4.0. And to summarize, I'd like to think about it a little bit differently. And let's start with MongoDB Stitch. So in MongoDB Stitch, one, it's GA now. So you should go and try it. And a lot of people are building real applications on that now. You can use Query Anywhere to make it really easy to actually access your data from your mobile devices, from a browser, from anywhere else without having to write a custom API call for everything. You can use functions to execute functions in a very lightweight serverless environment. So you can do sort of server-side coding without having to build up a lot of infrastructure. You can use triggers without anything else. If you've got an Atlas cluster, you can just use triggers just in very simple ways just to sort of make your applications easier to write and more real-time without having to do sort of anything else. And mobile sync is coming soon, so you can actually synchronize some of the data sitting in your Atlas clusters directly with your phones. In Atlas, we've added full CRUD support directly in the UI, both for regular clusters and for the shared tier clusters. We've added global clusters, so you can have great latencies for every user no matter where they are on the planet. We also added a free tier on Google. So now we have a free tier for Atlas both on Amazon and on Google, so you can do that. We've also added a lot of enterprise security features we didn't cover this morning. The most notable ones are a custom key management service. So you can use your own AWS KMS account to encrypt the data at rest. So if you don't want us to have access to the data anymore, you can just cut off our access and then we don't have the encryption key anymore, the decryption key anymore. We've added on-prem LDAP support. So if you've got your own LDAP servers that you want to use for database authentication, we can use those. So you can manage your users in one way. And we've added full database level auditing. So you can actually use full MongoDB enterprise auditing to do full auditing of all of your data sitting in all the operations against your Atlas cluster. And we've had for a while now a real-time import into Atlas. So you can migrate from your non-Atlas cluster to Atlas. And we've added support for sharded clusters into that tool as well. So now you can manage you can migrate a non-Atlas sharded cluster directly into Atlas. And of course, in the core MongoDB server, we've added a lot of enhancements on the query language, like date manipulation and string manipulation. We've added free monitoring. This is kind of an interesting piece. So any MongoDB 4.0 server now, there's a way, if you want, you can let it sort of start pushing data to the MongoDB cloud service that's built on that's part of Atlas. And so you can start getting some basic telemetry, just if you want, just as sort of a way to just help people debug stuff in real time if they want it. And of course, multi-document ACID transactions. So I hope this morning we've talked a little bit and sort of helped you understand how we think we're making MongoDB even better to build modern applications and why MongoDB is the best database for modern applications. And what we've done on the document model, distributed systems, and letting you run MongoDB even everywhere to make MongoDB the best database for any use case on any platform. I've had a great time this morning. I'm around all day. I'd love to talk to you, as many of you as possible, get your feedback, see what you like about MongoDB, see what we can do better. And I hope to see everyone the rest of the day and after the event at the little after party. So see everyone later, and have a great day in Chicago.